that y'all normally struggle with. Your understanding of what we're doing and how we're doing it. Now, coming up, because we'll do this today, then we're going to start our multiplication division tomorrow, and it'll take a day or two to do that. However, I won't be here Monday. Me and Miss Kendall are going to be gone for professional development over the new mathematics, or the new Oklahoma math standards. They're hosting a professional development, so we're going to be gone for that, okay? Now, depending on where you're at, you might be in here, you might be in the library. Either way, sorry, Tuesday. So on Tuesday, me and Miss Kendall won't be here for professional development because parent-teachers Monday. So on Tuesday, you're either going to be in here with a sub or in the library. Either case, what you're going to be doing is, and if you're in the library, I'm going to give Kara all of your tests. So even if you haven't taken it, I still have a test with your name on it, and you're going to have those there. And what I'm going to have you do is watch the video. I already have a video posted, or not posted, done and recorded over that test, going over every single problem. And so on Tuesday, what I'm going to have y'all do, you can do it in pencil, pen, whatever it is, follow along with it. Either if it's in here, we'll have it pulled up, you guys watch it and kind of go through it and see kind of how it works. And yes, and it's going to be, I think, probably in some areas a little frustrating, because sometimes, especially when I go through it, I've heard from y'all that I make it look a lot easier. And some of the stuff, once you see, especially the keys to it, you'll see that it's a lot easier than what you're thinking or making it out to be. There is a little bit of critical thinking with this one here on what we need to do and what we need to apply or multiply or get it to be. That's the challenging part to it. But once we get that and see that, this chapter is a lot easier than what you think it might be. Because with addition, subtraction, what I saw in several places there as I was kind of walking around, we really were trying to factor more than what was needed. Because when we talk about addition, subtraction, we need the denominators to be the same. If we add or subtract two fractions, the bottom of the fractions have to be the same. If they're not, we factor them to try to get them to be the same, but we don't mess with the numerators at all. We don't have to factor the numerators. We only have to factor the denominators to try to add or subtract. Once we finish adding and subtracting, simplifying everything in the top, then we factor to try to simplify. So when we look at this one here, the two denominators are x minus 5 and x minus 5, yes? They're already the same. So that means we can add the numerators. Now we can use parentheses here just to consider we're taking the quantity 6 and adding to it the quantity x plus 2. Now we don't normally use parentheses with addition because 6 is going to stay positive, and if we apply the positive sign to both x and 2, it's just going to stay the same. So we really have 6 plus x plus 2 over x minus 5. Combine like terms gives us x plus 8 over x minus 5. That's it. We can't simplify because x minus 5 and x plus 8, they are a single term. They're not the same. And that's it there. Because with addition and subtraction, before we start adding the fractions or subtracting the fractions, we need the denominators as simplified as they get, and then add or subtract the numerators. We don't try to factor sets of parentheses with the numerators until the very end. We don't simplify until we simplify. We're trying to get it simpler. Because if we look at this one here, the x squared plus 3x minus 2, we don't have to factor it at this point. Because we're adding and subtracting. We're adding and subtracting. Because the main thing we're wanting to factor or get to be the same are the denominators, yes? Two sets of parentheses, they're already factored. We don't have to do anything to them. And since they're both the same, we're able to add and subtract. X plus 5, x minus 2. And what we're doing is we're adding the numerators together. X squared plus 3x minus 2 plus 4x plus 12. I put the parentheses around it just to kind of have an understanding that we're adding these together. But again, with addition, we don't necessarily need the parentheses. The main case that we would need it is if we're dealing with subtraction, because this plus sign is applied to everything in that 4x plus 12. But since we're applying a positive to it, positive sign to it, the signs aren't changing. So we still have x squared plus 3x minus 2 plus 4x plus 12. So the numerator, we combine like terms. And since we're combining like terms, we're just adding or subtracting them from each other. X squared is the only term on top with, that is x squared, so it's by itself, it's just x squared. 3x and 4x are like terms, so 3x plus 4x is plus 7x. And lastly, negative 2 plus 12 is plus 10. But whenever we add or subtract, again, we want to get the denominators the same. Here they already were. Then we add or subtract the numerators. Now we would. Now we would factor. Because here, here we don't want to factor first. We don't want to factor first. Because we can, because for x plus 12, there is a greatest common factor of 4, because that does factor. Here, we would factor, well, it actually doesn't. X squared plus 3x minus 2 doesn't factor. Probably. But even here, x squared plus 3x minus 2, 4 times x plus 3. I can't combine anything here because the 4 is being multiplied by the quantity x plus 3. We don't have our like terms. For us to be able to actually add or subtract, we got to do what? Distribute the 4 back through and then combine like terms. Well, that's undoing what we just did. This is why we don't mess with factoring in the first step. We only deal with the denominators. We simplify those so we can add and subtract the numerators. But now, all the way down here, we've got everything simplified. We've added and subtracted. We've combined the like terms. We have it as one expression. Now we will factor. Once we have everything done, now we factor to see if one of these two factors on top matches the ones on bottom. Now, I realized this the other day. One way that we can kind of tell or possibly tell if we're going to have like terms, so the denominator does have x and x, yes? Are they factors of x squared? Yeah, factors of our numerator. Factors of 10. 5 and 2, yes? Because our top one's 5 and 2, and the denominator we have. So there's a good chance there might be something that matches up, because those are where our factors are going to be. Now, if we look at this here, factoring x squared plus 7x plus 10. We have our two sets of parentheses, because there is no greatest common factor. No number that can go into all three terms. What would our signs be? Positive and positive. Since the third term's positive, our signs are the same, and they match the sign of the middle term. All right? Factors of x squared. X and x. And factors of 10 that we want. 5 and 2, 2 and 5. And those would be the correct factors. Now, is there something in common on top and bottom? X plus 5. So these would cancel out, leaving us with x plus 2 over x minus 2. And this is indeed one of the ones from the test. But that's it. Yeah. I will, especially on Tuesday, because I'm going to give them all back so that you can, again, go through with the video and see what it is. And a lot of that, this is what the main thing with this chapter is in that test. It's just one little thing that y'all are missing. Because it will be probably not next week, but the week after. So looking at this one here, subtraction. Now, will we need to factor the denominators? Eventually, yes, but no, because for us to add or subtract, the denominators have to be the same. Are they the same? X squared plus 7x plus 12 and x squared plus 7x plus 12, they're already the same. So that means we can subtract the numerators. And again, this is problems like this here, when we deal with subtraction, this is why I put parentheses around both. It's very easy to just subtract the two and apply the negative only to the x squared, the first term. So we're applying it to all of them because we're subtracting it. So really what we're saying is that we're subtracting x squared from x squared. We're doing x squared minus x squared. We're taking negative 2x and subtracting from it negative 4x. We're doing 2x minus negative 4x. And we do 3 minus negative 5. We're subtracting each one. And if we think of it that way, the first numerator is still going to be x squared minus 2x plus 3. But if we're subtracting x squared, it's the same as saying negative x squared. If we're subtracting negative 4x, and negative make a positive. We apply the negative to 4x, we get plus 4x. And when we apply the negative to negative 5, we get plus 5. That's why I put the parentheses around both, just in case we have that negative that has to be applied to it. Combine like terms. Well, x squared minus x squared is 0. Only way we can get 0 is by subtracting something from itself. Whenever we divide something by itself, it is, anything divided by itself is 1. So the x squared and x squared cancel out. Negative 2x plus 4x is, and lastly 3 plus 5 is plus 8. Now again, once we finish adding and subtracting everything, now we simplify, now we factor. Because with addition and subtraction, except for the denominator, we don't factor the numerator until the very end. We wait to the very end to do that. So if I look at the numerator, 2x plus 8, is there a greatest common factor? 2, we can factor out, which leaves us with x plus 4. Is there a possibility that something will factor with the denominator? Because first term is x on top, yes? If we factored that, that would be coming from the factors of x squared. Okay, that does line up. 4 comes from the factors of 12. Well, 4 is a factor of 12, yes? So there's a good chance something will factor out. 2 sets of parentheses. Our signs would be positive and positive. Factors of x squared are, and the factors of 12, 3 and 4. If we checked it, we would have 4x plus 3x, which is 7x. That is the middle term we want. And we do see that these will cancel, leaving us 2 over x plus 3. Are y'all starting to see how these work? Yeah. Questions on this here? Now, it is nice when the denominators are the same. Now, when they're not the same, like this here, we need to get them to be the same. We need to get them to be the exact same. And this is where the least common denominator, least common multiple comes in. Least common multiple is the smallest expression that we can have that they will both be the same, that they will both be the exact same. Because anything we go over it will have to come back out. Because when we look at this here, x squared and 7x, if we want them to both be the same, we know that both have to have a what? X squared. This one has 2 of them, this one has 1, so they both need 2. Because when we do this, we always go up. We don't go down. And what I mean by that is we can't go from x squared to x. We don't want to remove them. We want to increase and go up and match. So if this one has 2 x's, we need this one to have 2 x's. So to do that, we can multiply top and bottom by x. Is x times x is x squared. They both have x squared now, yes? Yeah, so now this one is missing what, a 7. One of them has 7, the other one has to have 7 as well. So we have this here. So again, to get the denominators the same, we're really trying to match them up, make them be the same. So we multiply the one on the left here, top and bottom. 7 times 2 is 7 times x squared is 7.
So this isn't like where you do one side, you have to do the other.
Because that there, we're dealing with equations, equal signs, equality. And even with equations, we can still do this.
So we could have to do what Anila was saying if there was a
Equals.
Yeah.
We could still do this.
You could still do that.
Because if we look at either one of them, so 7 over 7, realistically, what is 7 divided by 7? If I multiply by 1, does it change anything? No. And that's why this works, is because I'm multiplying 2 over x squared by 1. It's a fancy version of 1, but 7 over 7 is still 1, yes? Because 14 over 7 is 2 over 1. I've not changed the value of what they are. They look different, yes? It's almost the same as saying that if you had 4 5s, 4 $5 bills, and I replaced it with a 20, or you had a 20 and I broke it into 4 5s. That's all we're doing. It's the same amount. We're just changing how it looks. And the reason we do that is, if we look at this here, because the other one, 3x over 7x squared, the x over x will reduce to 7x on bottom and 3 on top. But we couldn't add, or here, we couldn't subtract these two because the denominators aren't the. But now they are. And the denominator is 7x squared. We can now combine the numerators. Here we would subtract. And that's it. We're almost rewriting them so that we can easily combine the two.
I was thinking that you had to do like the 7x to make the other one.
So we're trying to get them to be the same. Now, if I ask for the least common multiple or least common denominator, our least common multiple are different. And actually, you don't have to. We want them to be that. That's what least common denominator, when most books or stuff talk about least common denominator for these, they're asking, what do we need to make the denominators be so that we can subtract them or add them together? What do we need to make the denominators be, the bottoms of these fractions be, so that we can actually add or subtract? Here it's 7x squared, but that's not what we multiply, because the first one has x squared. The only thing it was missing was the 7. The 7x was missing and x. And we multiplied it, we get the 7x squared. And that's it. Now, this is our final answer because 14 and 3x don't have any greatest common factors. There's nothing we can combine, simplify from there. That's as far as it goes. Questions on this here? So with this one here, we want them to be the same. And again, we're always going up. Now, 18 and 27, those aren't real easy numbers to find a greatest common factor for, or least common multiple. So one of the easiest ways I've seen to do this is either A, plug them in the graphing calculator, math over 1, down at the bottom, LCM, LCD. It'll do it for you. You can plug 1827, hit enter. It'll tell you what it is. Or we can add them. 36, 54, and then 6, 7, 8, 2, 72, 90. I'm just adding 18. 18 plus 18 is 36. 36 plus 18 is 54. 54 plus 18 is 72. I'm just continuously adding 18 to itself. If we add 27 to 27, we get 54. Well, first number that I can make 18 and 27 be is 54. And that's all it's trying to see is what is the smallest number we can turn both 18 and 27 into going up. Because least common multiple, we're increasing one or both. Greatest common factor, we're going down. Smallest number, that will go into all of them. So what we're saying for both of these here, we need to turn both of them into 54 for them to be the same. Does that make sense? And these here, I always find these single terms harder to find a least common multiple for. I like parentheses better because it's just looking at them, which one has each set. Well, for 18, we had to add 18 because this is 1, 2, 3 times, yes? So 18 times 3 is 54. 27, we had to do it once, twice, yes? So this would be 2 over 2. Because when we do that, we will get 54 and 54. Now let's look at the x's. The one on the left has how many? 3, because we have x to the third. The one on the right has, indeed. So how many do we need? 3, because the one on the left has 3, the one on the right has 2. To get them to be the same, they both need to be 3. And I know what you're getting at, yes. Because they both need to have x to the third, yes? Well, the one on the left already has it, yes? The one on the right needs to have it, so it needs to be multiplied by x over x. So we have 2x over 2x, yes? Because x squared times x is x to the third. Are we good with that there? Now, if we look at the y's, the one on the left has 1, the one on the right has 3. So we need them both to have 3. The one on the right needs 3 more y squared. So if we're talking about the least common multiple, least common denominator, which essentially are the same thing, just where they're placed, our least common denominator is 54x to the third y to the third. Because that is the first term that we can make both of these be the same. So we have to multiply them by, because we're multiplying one by 3y squared, we're multiplying the other one by 2x for them to be the same. Now we multiply the numerator. 3y squared times 1 is 3y squared. 2x times 5 is 10x. If we add the numerators, y squared plus 10x. 3 and 10 don't have a greatest common factor. Y squared and x don't. They're not like terms. That is simplified as it gets. Questions on these here? Hopefully these are becoming a little bit easier than they were the first time around. We ready for the next one? The next one, I find these to be a lot easier than the ones we just did. Because if we look at these two, x plus 3 is a single expression. X by itself is a single expression. They're not the same. And the reason I find these a lot easier than the previous one is we can look at both. The one on the right is x. The one on the right is x plus 3. The one on the left is x, yes? So the one on the left needs a what? X plus 3. So on top and bottom we can multiply by x plus 3. And again, just like we were doing before with 7 over 7, because 7 divided by 7 is 1, yes? We've done that. We've done that time and time again. Here, x plus 3 divided by x plus 3 is 1. It's just a fancy version of 1, but it's still 1. What's the one on the right missing? Missing, Ned? So we have x over x. Now the denominators we don't distribute through. We're not going to distribute it through. And I'm going to flip back a few pages. Because here, we have x squared plus 7x plus 12, yes? In this form, because we got down to here, could we just simplify anything at this point? Well, no, we needed the denominator what? Factored, yes? Because once we have it factored, then we could cancel out the x plus 4. Here, when I multiply both sides by x, I multiply this by x. They will both be the same, yes? We could distribute through, but then we'll have to factor it right back out for us to be able to simplify, cancel on top and bottom. Also, with the denominators of both of these here, do we do anything to them with addition and subtraction? No, they're both the same, yes? Because when we combine, we're only adding or subtracting the numerators, the top of the fractions. The denominators are the same. If I don't have to add or subtract, we can just leave it as x times x plus 3. I don't have to multiply x and x and 3. I don't have to distribute that through. Because when we add them, it's still going to be x times x plus 3. There's nothing we're having to combine. This is why we don't distribute through the denominator. But as we've seen a few times already, the numerators, we're going to actually have to add or subtract. We have to combine those like terms. So with the numerator, we have to distribute the 5. 5 times x is 5x. 5 times 3 is plus 15. 7y times x is 7. Are there any like terms once we drop those parentheses? X, y, and 15x aren't the same. And that's as far as we go. Even though there is an x in common with 5x and 7x, since there's not one in common with the 15 as well, we can't really factor it out and be able to cancel. Or, thank you. 5x. Should be 5x, thank you. I think I mistakenly wrote it in with that parentheses. But that's it. Questions on any of this here? Now this one here, we can definitely see the denominators are not the same. One is 3x squared minus 6, the other is x squared minus 4x plus 4. So before we start trying to multiply both sides by something to get them to be the same, we need to factor. If we look at 3x squared minus 6x, well, with 3x squared minus 6x, there's no constant term. There's no number by itself. But there is a greatest common factor. Because we need to see what will go into both 3x squared and 6x. 3x. Because 3 will go into both 3 and 6. 3 is divisible by 3, and 3 is divisible by 6. We can divide 3 into both of those, yes? They both have an x, so we can pull that out as well. So if I factor 3x out of 3x squared, or I divide it by 3x, 3 divided by 3 is 1. X squared divided by x is just 1x. Minus 6 divided by 3 is indeed 2. X divided by x is 1. 2 times 1 is just 2. So as we divide it out, 6x divided by 3x, we're just saying 6 over 3 times x over x. Now for this here, we have our two sets of parentheses. Yeah, we'll most likely finish this up tomorrow. That's fine. X squared minus 4x plus 4. Since the 4 is positive, our signs are the same and match the sign of the middle term, negative and negative. Factors of x squared are x and x. And factors of 2 we want are 2 and 2. All right, we got 10 minutes, okay. Now, looking at both of these here, we need to get the denominators to be the same, yes? Now, in both denominators, we have an x minus 2, yes? So that's good. We do have that matching in both. But the one on the right has 2 of them, yes? So the one on the left needs how many of them? 2. It only has 1, so we need to multiply top and bottom by x minus 2. Now do both denominators have 2 x minus 2's? Yes. Is there anything else we need? So the one on the right needs to be multiplied by 3x over 3x. So both denominators are now 3x times x minus 2 times x minus 2. And we do this here just in case one of the numerators does have a factor that is x minus 2. Here we distribute 7 times x is 7x. 7 times negative 2 is negative 14. 3x times x squared is 3x cubed. We can add them. Now again, when we add, we don't need the parentheses because addition's not changing signs. It's not changing it from positive to negative or negative to positive. That's only subtraction. Now, if we want to write it in standard form or proper form, it's just decreasing powers. We would just move the 3x cubed up front because it's positive, stays positive. It's just rearranging it. That's it. We haven't had one that actually factors yet, but Any questions on this here? Any questions on any of this here so far? Now, hopefully this is starting to make a little more sense seeing it again. Yep. We're going to stop there for today.